Hello students, welcome to section 10. In this section, we're going to learn how to use the Kramer's rule to solve equations. So we are going to pick a random equation. Let's say I have 2x plus 5y is equals to 19 and I have 3x minus y is equals to 3. Now again, this is my equation number 1. This is my equation number 2. Now as we learned from the last section, we need to make sure that our values are correct. So the first equation is a1x plus b1y is equals to c1. Pardon me, the first equation is in the form of a1x plus b1y is equals to c1, and the second equation is in the form a2x plus b2y is equals to c2. Now using this, we can compare both the equations and find the values for a1, a2, b1, b2 and c1, c2. So I'm going to write those down. So I have a1 is equals to 2. I have a2 is equals to 3. I have b1 is equals to 5. I have b2 is equals to minus 1. Now the reason b2 is minus 1 because if you pay attention to the second equations, we can see that this sign is plus and this sign is minus. So therefore, if I write plus here, I need to take minus 1 inside and multiply it with y. Therefore, the coefficient of y becomes minus 1. This minus 1 becomes the coefficient. Now, once we have learned this, we need to make sure that in future problems we do not make any such mistakes. Now, b2 is minus 1. I have c1 as 19. I have c2 as 3. Once I have this, all I need to do is find the values of determinant d, determinant dx, and determinant dy. So I'll start with determinant d. As we remember, determinant d is calculated by, let's remember it back again. I have a1, a2, b1, b2, c1, c2. Now in order to find determinant d, I'm going to erase the constant column. So this goes away and my determinant is left with this. And this is my determinant, which is a1, a2, b1, b2. Now once I have this, I'm going to use a1. I'm going to use a1, a2, a1, a2, b1, b2, which is equals to 2, 3, 5 and minus 1. Now using the determinant evaluation, we are going to calculate this value, which is 2 times minus 1 minus 3 into 5. So 2 times minus 1 is minus 2 and minus 3 into 5 is 15. So the value of d becomes 17. The value of d becomes 17. Now if anybody might have forgotten how to calculate the determinant values, we have the determinant is calculated in this fashion. We have a, b, c, d. This is equals to ad minus bc. So this multiplies with this minus this multiplied with this. This is how we calculate determinant values. Now moving on to dx, we have d is equals to plus 17. So now for dx, now back again, we have a1, a2, b1, b2 and c1, c2. Now in this case, we need to calculate the x determinant. So whenever we need to calculate the x determinant, we need to make sure that the coefficient of x goes away. So I'm going to take away a2, a1, this goes away, and now this c1, c2 column completely comes where a1, a2 earlier was. So c1, c2 from here comes over to this place. So this will be my determinant for dx. So now I have here C1, C2, B1, B2, which is equals to C1 is 19, C2 is 3, B1 is 5, and B2 is -1. Now once we get this, again using the determinant formula, I can get 19 times -1 minus 5 into 3. So this is -19 minus 15, which is equals to -34. Now once I get dx is equals to -34, I need to move to dy. I have dy is equals to, now again we need to understand how to calculate the determinant. So I have a1, a2, b1, b2, c1, c2. In this case we are calculating the y determinant, so we need to remove the y coefficient. So this is my determinant. I'm going to remove b1, b2, and then c1, c2 replaces this complete column. So I have c1 here, I have c2 here. This goes away. So this is my determinant for dy. I have a1, a2, c1, c2. So now my c1, c2 values are 19, 3, and my a1, a2 values are 2 and 3. So calculating this, I have 2 into 3 minus 19 into 3, which is equals to 6 minus 57, which is equals to minus 51. Now, in order to calculate the x and y values, we do this. X is equals to dx divided by d, and y is equals to dy divided by d. So let's check all our values. Our d value was -17. Pardon me, I missed a negative sign here. This is -17. So my d value is -17. So x is divided by -17. Similarly, y d value is -17. Now back to dx value. Dx value is -34. I have -34 here, and my dy value is -51. So as you solve this, you will get the answers as +2 and y is equals to +3. So I have x comma y as 2 comma 3. This is my solution. You can check the answers by using different methods. Now we're going to solve a problem which has much more multiplication in it, and we're going to understand why Kramer's rule is very important to learn. So I have 93x plus 107y is equals to 200, and I have 107x minus 93y is equals to 14. This is my equation number 1. This is my equation number 2. Now again, first equation is compared to a1x plus b1y is equals to c1, and second equation is compared to a2x plus b2y is equals to c2. Now my a1 value is 93, a2 value 107, b1 value is 107, b2 value is -93, c1 value is 200, and c2 value is 14. We have to calculate determinants. So first I'll start off with d. D is calculated by a1, a2, b1, b2. Just to be sure, we're going to understand how did I get this. So I have all the coefficients in one place, b1, b2, c1, c2. In order to calculate d, I need to eliminate C1, C2 column. So this has to be eliminated. Once I eliminate this, I am left with B1, B2, A1, A2, which is the resulting determinant. So once I get this, I need to just substitute the values for A1, A2, B1, B2. So I have 93, 107, 107, minus 93. All the values have to be written as they are. So now solving the determinant, I have 93 into minus 93 minus 107 into 107. So now calculating all these values, 93 times 93 is, this is 9, 7, 2, cross 9 times 3 is 27, 7, 2 goes over, and I have 81 plus 2, which is 83, so I have 8, 3, so I have 9, 4, 1 carries over, which is 6 when added with 2 and 3, and I have 8. So 93 into 93 becomes minus 8649. So this is minus 8649. Now I have to calculate 107 into 107. So I have 107, 107, 7 sevens are 49, 9, 4 goes over, 7 times 0 is 0, 0 plus 4 is 4, 7 times 1 is 7. Again cross, 0 sevens are 0, 0 zeros are 0, 0 times 1 is 0. Crossing again, 1 times 7 is 7, 1 times 0 is 0, 1 times 1 is 1. So I have 9, 4, 7 plus 7, 4 again, 1 goes over, 1 here and 1 in the 10,000s place. So now here I have minus 11449. So now both these values have to be added because both of them have negative signs. So I will just add them, 11449, 8649, 9 plus 9 is 18, 8, 1 carries over, 4 plus 4, 8 plus 1 is 9. Then I have 4 plus 6 is 0, 10. That means 0 here, 1 carries over, 1 plus 1 is 2, 2 plus 8 is 10, 0 here, 1 carries over. So I have 20098 as my value for D. So this value becomes minus 20098. Now moving on to the dx value. So I have now dx is equals to C1, C2, B1, B2. Again, we just revise how we got to this. So I have A1, A2, B1, B2, C1, C2. In order to calculate the X determinant, I need to remove the A1, A2 column. So I am going to eliminate this column and bring in C1, C2. So A1, A2 goes away. I am left with C1, C2. So this is my determinant for dx. Now getting the values for C1 and C2. My C1 value is 200. C2 value is 14. B1 value is 107. And B2 value is minus 93. So now here I have 200 into minus 93 minus 107 into 14. So 200 into minus 93 is minus 18600, and 107 into 14 can be calculated here. So I have 4 sevens are 28, 8 goes here, 2 carries over, 4 zeros are 0, plus 2 is 2, 4 ones are 4, 1 times 7 is 7, 1 times 0 is 0, 1 times 1 is 1. So this is 8, 9, 4, 1. So here I have minus 1, 4, 9, 8. Now again, both the signs are negative and therefore they will add up. So I have 186001498. So here I have 8, 9, 0, 1 carries over, 0, 8 plus 1 is 10, and then 1 carries over here again. So I have 20098 again, and the value is negative because sign does not change. So here I have minus 20098. So x is calculated as dx divided by d. Now my dx value is minus 20098 divided by my d value is minus 20098 as well. So I have minus 20098. Both these values cancel out, which is equals to 1. So my x value is 1 here. Similarly, following the same procedure, I can get the value for y. So we're going to just do that. So dy is equals to a1, a2, c1, c2. I have a1, a2, b1, b2, c1, c2. Again, we are calculating the y determinant, so I need to eliminate the y coefficient. So this column has to be removed. So I'm going to remove this and bring in c1, c2. So this is my resulting determinant for dy, which is what we have written on the left hand side of this page. Now, my a1 value is 93, a2 value is 107, c1 value was 200, and c2 value was 14. Once we get this, calculating, we have 93 times 14 minus 200 times 107. So 93 times 14 is 4 3s are 12, 1 carries over, 4 times 9 is 36, 36 plus 1 is 37. So here I have 372 cross, 1 times 3 is 3, 1 times 9 is 9. So this is 2, 7 plus 3 is 10, 0, 1 carries over, 3 plus 9 is 12, plus 1 is 3. So I have 1302. 1302 minus 200 into 107 is 21400. You all can calculate this. Now here we have 21400, which is greater in numeric value, has a negative sign, and 1302 has a positive sign. So both these values will be subtracted. So I have 21400, 1302 cancels. I have 3 here, I have 9 here, I have 10 here. So 10 minus 2 is 8, 9 minus 0 is 9, 3 minus 3 is 0, 1 minus 1 is 0, and 2 minus nothing is 2 again. So now here I have my value as 20098, and remember 21400 was the bigger value with a negative sign, so the negative sign stays. Once I get this, all I have to do is y is equals to dy divided by d. Value of dy is minus 20098 divided by the value of d was minus 20098, which is both are the same values, so both values cancel out, and I have y is equals to 1. So therefore x comma y is equals to 1 comma 1. So this is my solution. As we can see, even though I had big values, just by simply using determinant method, I get the answers pretty quickly. Now we're going to practice our practice at 1.3. In the next section, we will be covering few questions and an extra question out of the textbook. Hopefully this video was helpful for you. I have a few extra questions just for practice before we start practice at 1.3. Make sure you do try them so that you understand how to solve Kramer's rule much quickly. These are the following questions. I'll keep the video on for some time. You can write these down and make sure you submit them whenever the school reopens as extra work. This section will end now. Thank you.